So if you'll recall, so far we've talked about two types of chemical bonds. We've discussed covalent bonds and we've discussed ionic bonds. Remember, the covalent bond is the one that shares electrons, and the ionic bond is the bond where electrons are transferred from one atom to the other, thus charging them, and opposites are attracting like magnets. Today, we're going to focus on the third chemical bond. This is a hydrogen bond. Hydrogen bonds link two polar molecules together. Okay, this is not talking about linking two atoms together. That was like the ionic bond that we were talking about that used two charged ions, those two atoms, and linking them together. This is actually taking whole molecules. Remember, a molecule is two or more atoms that have been chemically combined. So we're taking two of those big molecules and linking them together. Just a couple of highlights about the hydrogen bonds. They are very weak bonds. They form when the molecules are close together, and it's important in the shape of DNA and proteins. As we've seen already in the macromolecules, those shapes are very complex, and hydrogen bonds are used within those macromolecules. A polar molecule has unequal distribution of charge. That means that in the molecule you're going to see that there's a positive side and a negative side. So it's unevenly distributed. A nonpolar molecule has equal distribution of the charge. It's going to be nice and even all the way around. So an example, in water, electrons are shared unequally, so the different parts of the molecule have different charges. I'm going to show you a picture right now of what this looks like, so that way you can kind of get a visual. I want you to also draw this into your notes and label all the parts. So make sure that you're writing in that this is the more positive, this is the more negative side. Okay, so I'm going to describe this to you. Here we have the oxygen portion of water. Remember, it's H2O, so there's two hydrogens, one oxygen. In the oxygen atom, you'll see that all of these electrons are left out on the side over here. Whereas the hydrogen atoms, there's no electrons on this end, thus it makes it more positive on this side and more negative on this side. That is a polar molecule. It's positive on one side, negative on the other. Once again, go ahead and pause the video, catch up, make sure that you've got the previous page's information in, make sure you've got this picture drawn, and then come back to the video. Okay, next I want you to, underneath your picture of the water molecule, I want you to draw this diagram showing how water molecules will form hydrogen bonds. Okay, so what it's showing here, and I'll describe it to you, and then you can draw it however it makes sense to you. We have our water molecule here, with the positive side next to the hydrogens, the negative side here where the oxygen is. Just like in our ions on the ionic bond, opposites attract. So positive and negative is going to try to come together. So if you see here, we've got a positive hydrogen area trying to link up with the negative oxygen area. So positive here at the hydrogen, negative at the oxygen. Negative at the oxygen here, positive hydrogen here. So you see where all those bonds are being formed. It's anywhere the negative side right here is coming close to a positive side. So once again, draw this diagram how it makes sense to you, then come back to the video. So the hydrogen bonds are what give water these unique properties that it has. It has four unique properties that we're going to discuss, starting off with cohesion. Cohesion is defined as the attraction between water molecules, and this is what creates surface tension. Okay, so surface tension is the bubbling that water makes. So, for example, when water forms droplets, that is because of cohesion and the surface tension. This is what also allows water to move up a tree. Okay, so like when it's moving up the tree trunk, being drawn out into the tree, that is because cohesion. This is also what enables light animals to walk on water. So you've seen like bugs sitting on top of water before. That's because cohesion. There's a strong surface tension there, and that allows them to be on top of that water without falling through. Another property is adhesion. Adhesion is the attraction of water to other polar substances. So this is what allows water to stick to glass. This is also what makes water stick to the vessels inside of a tree. So it's going to be attracted to other polar substances. We'll talk about that. Also comes into play when we discuss how it can dissolve salt to create the salt water. It is also a versatile solvent. Okay, and what this means, many things can dissolve in water because it is a polar solvent. That means a substance in which something can be dissolved. This allows for necessary nutrients to be dissolved in the body fluids for transport. So the fact that it's a versatile solvent and it can break things down, we use that in our bodies to carry nutrients all over the body because our body has a lot of water in it and it can carry those substances to where it needs to go. Okay, next you're going to draw a picture that will show how water can dissolve in ionic compounds such as salt. So we're going to show how water is going to break down NaCl. So here you can see we have our sodium ion here, our chlorine ion right here. They've been broken apart so far, and you can see how the positive sodium has all the negative portions of water around it. The chlorine is negatively charged and it has all the positive hydrogens surrounding it. So that's how it's breaking apart. It's pulling apart that polar molecule because it's charged itself. So go ahead and take a second, draw it into your notes the way that it makes sense to you. Make sure you're labeling too. Like label that this is positive and this portion is negative. Make sure that you label that this is negative and these are positives. Remember, opposites attract to each other. The last property of water is density. And water is unique in that its solid form of ice is less dense than the liquid form of water. That's unique because most items out there get more dense as they become solid. And water is the exact opposite of that, where ice becomes less dense than the liquid. Okay, for your summary of these notes, I want you to list and briefly describe the 4 important properties of water. So go ahead and look back at your notes that you've just taken and look at the 4 properties of water and put them into your own words. Just real brief, real simple. This is the end of the notes, so go ahead and make sure that you've filled in everything. Go back into these notes if you think that you missed something. Make sure that you are completely done, and then you can move on to the next video.